Seals are so agile that they are nearly impossible for a heavy shark to catch in a standard underwater pursuit. This is a 14-foot, 1-ton great white shark, suspended 3 meters above the surface of the ocean. Water is nearly 800 times denser than air. Propelling a mass this large out of a fluid that thick requires an immense expenditure of kinetic energy. Sharks only pay that energy cost because of their primary prey, the Cape fur seal. These seals are so agile that they are nearly impossible for a heavy shark to catch in a standard underwater pursuit. To see how a shark actually achieves this flight, we have to look past the surface spectacle and descend 25 meters to the ocean floor. The air jaws phenomenon is a mechanical solution to a specific biological hurdle, a method of using depth and speed to bridge the gap between a heavy predator and a much faster target. Seal Island is a rocky outcrop defined by a sharp 25-meter drop-off. This underwater cliff provides the depth needed to stage an attack. From the bottom, the shark relies on a biological adaptation called countershading. While the shark's belly is white, its dark gray back dissolves into the murky, rocky seabed when viewed from above. This explosive ambush depends on the shark remaining motionless and undetected on the seafloor. Looking up from the depths, sunlight compresses into a bright, circular window due to water refraction, Snell's window. When a seal crosses this light, it becomes a sharp, dark silhouette, providing the shark with a high-contrast target lock from 25 meters below. The shark initiates a strictly vertical rush, targeting the seal's blind spot directly beneath it. By attacking straight up, the shark hides its 14-foot length. To the prey above, the predator only appears as a tiny, rapidly expanding dark circle. Acceleration is critical. The shark surges through the water column, reaching speeds exceeding 40 kilometers per hour before impact. This vertical trajectory and high velocity minimize reaction time, closing the distance before the prey registers the threat. The shark aims to strike at the exact moment the seal surfaces for air or travel. The momentum of that 40-kilometer-per-hour rush is so high, the shark cannot stop. It carries the 1-ton animal up to 3 meters into the air. Seals often detect the attack a split second before impact, triggering a series of sharp, evasive zigzags. If the initial strike misses, the shark uses specialized fast-twitch head muscles to execute lateral jaw snaps, a secondary reflex to catch a dodging seal. This explosive breach is ultimately a high-stakes kinetic gamble, an all-or-nothing burst of speed supported by rapid-fire physical reflexes at the surface. Despite this mastery of stealth and velocity, the hunt is a balanced contest. Seals still manage to escape roughly 50% of the time. Breaching and high-speed kinetics are used by other shark species for very different purposes. The pelagic thresher shark uses kinetic energy to weaponize its scythe-like tail. By whipping its tail overhead at high speeds, the thresher creates a pressure drop that generates cavitation bubbles. This releases a shockwave powerful enough to stun multiple fish at once. The great white's breach is a demonstration of evolutionary specialization, a strategy where light, depth, and velocity are harnessed to secure a meal in an environment where the prey often holds the advantage.